Good morning. I am Melvin from Savita Engineering College. I am a final year CAC student. This is my project, Flash Study AI, Personalized AI for Smarter Study. Introduction. The future of learning is not in classrooms, but in intelligent ecosystem. Students today drown in information, yet thirst for personalized guidance. Flash Study AI rises as a digital mentor, blending productivity, skill growth, and adaptive learning. It transforms passive study into immersive AI-driven learning journey. More than a tool, it's a companion for mastery. It adapts to your pace, your style, and your goals. Refining education, it empowers learners to unlock their fullest potential. Statement of the problem. Traditional learning methods are often rigid, one size fits all, and fails to adapt to learner's pace or style. Students face information overload yet struggle to extract meaningful personalized insights for their growth. Existing tools like ChatGPT or Perplexity provide answers but lack structured sturdy features such as quizzes, flashcards, and progress tracking. Learners need a personalized, intelligent ecosystem that bridges productivity, skill growth, and adaptive learning to transform fully educationally. Scope of the project: redefine learning, create an intelligent AI powered ecosystem that evolves beyond traditional study methods. The key challenges are addressing information overload, lack of personalization, and passive learning habits. Core approach: integrate automation, interactivity, and adaptability into every session. The core objectives: AI Companion. It is to develop an AI driven system that personalizes content based on the user progress. Automated conversion instantly transforms raw materials, PDFs, textbooks into structured interactive aids. Multimodal environment to support visual, auditory, and kinesthetic learning styles seamlessly. From passive reading to active learning. Interactive experience which are shifting studying from solitary reading to guided engagement. Local processing uses lightweight local hosted AI models instead of cloud hosted AI models to conserve space and to fully rely on local source without any internet. Key benefits: ensures data privacy, offline accessibility, and low resource consumption. Scalable and future ready architecture. Modular design, extensible framework ready for LMS, collaboration tools, and multilingual support. Easy deployment, platform agnostic setup via Docker for institutions or individuals. Aligns with UN SDG 4, quality education to promote inclusive and equitable learning. Methodology: how FlashCity AI works. FlashCity AI follows a structured multi-stage pipeline to transform raw study materials into interactive learning tools. Each stage is designed to ensure accuracy, relevance, and pedagogical value. Stage 1: Input and Processing. Users upload study materials in PDF, doc, or text format. System extracts and cleans text, removing formatting artifacts and noise. Content is chunked into meaningful segments for targeted processing. Stage 2: Vectorization and Retrieval. Text chunks are converted into numerical embeddings using transformer models. Embeddings are stored in a vector database, FASE/Chroma, for fast semantic search. Enable smart querying. Users can ask questions and retrieve relevant sections from their notes. Summarization, which is stage 3. Each text chunk is summarized into LEP models, using NLP models, T5 BART for an example. Chunk level summaries are combined into cohesive document level overview. Output is concise, coherent, and retains key concepts for efficient review. Creating engaging study aids. Once content is processed, FlashCity AI generates a suite of interactive learning resources designed to promote active recall and long-term retention. Stage 4: Quiz generation. Automatically creates multiple choice questions MCQ from content. Implements scalable difficulty levels easy, medium, hard, where the user can choose for themselves to test their goals and their limits. Generates plausible distractions using similarly and common misconceptions. Stage 5, Flashcard creation. Identifies key terms and concepts using NLP techniques. For example, POS tagging, dependency parsing. Pass each term with a clear, concise definition or explanation. Formats cards for space repetition to optimize memory retention. Stage 6, Audio summaries. Converts text summaries into natural sounding speech using TTS engines. Support offline listening and multimodal learning. Ideal for commutes, reviews, and accessibility. This is the architecture diagram, or rather the flow diagram of my project, where the entire project process works. This is a use case diagram. Use case diagram is a graph or actors set of use cases enclosed by a system boundary communication association between the actors and users and generalization among use cases. The use case models defines the outside and inside of the system's behavior. This is the use case diagram of my project where the student and AI engine are the actors where the rest of the things are happening. Class diagram. Class diagram is a graph of actors or use cases enclosed by system boundary, communication association between the actors and users, and generalization among use cases. The use case model defines the outside actors and inside as system behavior. Class diagram. Class 3 AI system. This is the class diagram of my project. Sequence diagram. There are another type of interaction-based diagram used to display the workings of the system. They record the conditions under which objects and process cooperate. It is a construct of message sequence diagrams, or sometimes called event diagram, event scenarios, and timing diagram. This is the sequence diagram of my project. The algorithms used in my project are transformer-based text summarization algorithm. The core technology with Flash Theory utilizes this to generate accurate summaries from large PDF. LED, long former encoder decoder, optimized for long form content. T5, text to text transfer transformer, ensures concise and coherent output. Self attention mechanism enables the system to understand long range dependencies linking related concepts distributed across multiple pages of academic documents. Optimized for learning. The LED model uses sparse attention, allowing it to process and summarize content that exceeds traditional token limits of standard models. Sentence embedding algorithm to support flashcard generation, quiz generation, and semantic similarity detection. Flash3AI uses a sentence transformer model, all mini LM6L6V2. Sentence transformers map sentence into fixed length numerical vectors that capture semantic meaning rather than surface level word similarity. These embeddings enable the system to identify key concepts, group related ideas, and generate meaningful question answer pairs. Adaptive learning algorithm. Flash 3AI incorporates an adaptive learning algorithm that dynamically adjusts content difficulty and focus based on user performance and feedback. This algorithm combines rule-based logic with performance metrics such as quiz scores, number of attempts, and accuracy levels. Based on these factors, the system prioritizes weaker topics and reinforces key concepts, creating a personalized learning experience. Hardware and software selection. Hardware environment. Processor. Intel Core i5 equivalent or higher. Hard disk. 256 GB RAM or higher are the necessary required for a project to run. RAM. 8 GB minimum. GPU, which is optional since we are using a local models which doesn't require that many GPU, but it is best to have more GPU power. Software environment. Operating system. Windows 10, 11 or even Linux. Backend language Python, backend framework Flask, deep learning framework PyTorch, NLP libraries, Hugging Face transformers, and sentence transformers. Implementation. Modular platform. An AI power system is designed to convert raw study materials into interactive resources using advanced NLP. Processing pipeline. Input stages. Users upload PDF documents via the front-end interface. Pre-processing. Backend extracts text, clean noise, and chunks content into manageable segments. AI generation. Transformer-based models generate summaries, flashcards, quizzes, and mind maps. Backend and technology stack. Flask REST API manages all operations including file handling, AI processing, and data persistence. Semantic understanding utilizes sentence transformer models for smart search and concept similarity detection. Data management stores generated artifacts as unified study sets to ensure consistency. User experience and scalability. Key features include dashboard analytics, audio playback, and progress tracking for personalized experience. Future ready. Modular architecture ensures scalability, maintainability, and seamless integration of new tools. This is the important core segments of my project. This is the app.py, which is works in the backend of my project, where every process is interconnected with each other. So the entire backend process is called from this code segment. This is the output of my project. This is the main menu, or rather the menu where the user comes into when my project opens, which is acts as a central entry point for Flashy AI system. It allows users to create or select a subject-specific workspace, enabling organized and focused learning. Hub functions are core control center of the Flacity AI. It integrates all major learning tools and provides a unified environment for content interaction. Dashboard. The dashboard module is responsible for managing uploaded PDF documents. Users can upload, view, and delete academic PDFs related to the selected subjects. This is the summarizer and the output of the summary. The summary model provides AI-generated concise explanation of uploaded documents. Using transformer-based natural language processing models, the system extracts key ideas, definitions, formulas, and important explanations from large academic PDFs. This is the output of the quiz. The quiz model dynamically generates question set based on semantic content of the uploaded document. The system creates concept-based questions rather than simple factual recall questions, helping users assess the understanding of the subject matter. This is the output of the flashcards. Flashcard module converts important concepts, definitions, and key points into short question answer pairs. These flashcards are generated using semantic embeddings to ensure relevance and contextual accuracy. This is the output of the mind map. The mind map module visually represents the relationship between the key concept extracted from the document. It organizes information hierarchically, showing how many main topics connect to subtopics and supporting ideas. This is the output of the Smart Search. The Smart Search module enables semantic searching within uploaded documents. Unlike traditional keyword-based search, Smart Search understands the meaning of user queries and retrieves contextual relevant information. These are the test cases I use for my project. For uploading PDF document, to upload a valid PDF file as an input, the output of the PDF file should be uploaded successfully, and it is. These are the some of the test cases I use for my project. This is the test case for upload PDF document, the test case for text extraction and pre-processing, the test case for document summarization, the test case for flashcard generation, the test case for quiz generation and evaluation, the test case for smart search or semantic search, the test case for dashboard and content management. Finally, the results. Summarization accuracy is 91%. Flashcard relevance score is 93%. Quiz questions correctiveness 90%. Semantic search precision 92%. If I integrated more app, online APIs, I could have improved the accuracy above 95 or rather 98%. Inference results. Effective extraction of key concepts, accurate semantic understanding of study materials, faster content comprehension, and significantly improved learning. Efficiency through AI-driven summaries, flashcards, quizzes, mind maps, and smart search. Conclusion. Flashy AI bridges the gap between traditional study methods and intelligent AI-driven learning. By offering summaries, quizzes, flashcards, progress tracking, and gamification, it transforms passive study into active engagement. The project empowers students with personalized, efficient, and accessible learning support anytime, anywhere. More than a tool, it is a step toward SDG for quality education and innovation in EdTech. With further refinement, it holds the potential to scale into real-world learning company for higher education and beyond. Future work. Adaptive learning mechanism. Future iteration will dynamically adjust summaries, quizzes, and difficulty levels based on real-time user performance and learning patterns for truly personalized experience. Multimodal and format expansion. Plans to include audio summaries, voice queries, and interactive mind maps alongside OCR support for handwritten notes and scanned images to cater to diverse learning styles. Scalability and institutional integration. Transitioning to cloud-based infrastructure and distributed processing to handle large user bases while integrating with learning management systems (LMS) for seamless academic adoption, advanced AI capabilities, incorporating retrieval augmented generation (RAG) and advanced reasoning models to significantly improve accuracy and evolve the platform into a long-term conceptual mastery tool. These are the references I use for my project. Thank you. Now, we will move on to the demo of my project. This is my project. My project is divided into two parts, the backend and the frontend. The backend contains all the codes related to the backend functioning and the frontend, which is via Node.js and White. In the backend, there is locates the local models, the routes which the all the tools and the routes related to the tools are saved here. This is the routes for flashcards, mind map, quiz generation, total save routes, and even for summarizer. And the saves, it is for the saves that is created by the users for their own studying purposes. There is utils in which all the working codes of the tools are present here. The app.py, which is actually a very important part of the backend, where this backend app.py code calls the entire backend function. While the rest is here, we will move on to the front end, which holds all the front end components in SRC about the dashboard, hub, and everything related to the front end. Now I'll just run the program to show you guys. I created my project using an environment to avoid any errors in the future. Now cd backend python app.py. I'll also run the front end. Well, it seems the environment is already on, so I'll just cd front end. Okay, the front end is running now. As for the backend, it is also active. Let's move on to the site. This is the intro splash screen of my project. And finally, this is the main menu where everything is present. I made a main menu like a video game, so it somewhat self-explained what the button continue, new save, load save does. And as for the about, it's about my project and my team, which contributed to the development of this project. Now, for testing, let's create a new save. I want to create a save for subject physics. It's for my name, Melvin. This is the hub of my project where the user interacts with all the tools present in the FlashStudy AI. If you press the tab, the option will pop up which you can go to the dashboard or to the main menu. The other three tools will not unlock until the PDF is uploaded. Let's go to the dashboard. Now, I upload a sample PDF which is located in, well, here. You can upload any number of PDFs here as each PDF is only linked to a single hub where each PDF utilizes the same hub but while retaining its own data, so a single save can have multiple amount of PDF uploaded to it and multiple number of users. If you click on it, it will take you to it. Now the backend is working and creating the summary from the summarizer. It will take some time depending on how many pages there are. If the PDF received is in text format, it will not take too much time. If it is in the form of an image or something else, it will convert into OCR and it will take quite some time. But Not many projects can do this. Let's just see what is happening. There are lot of numbers, lot of keywords and words in the PDF. So I'm splitting it chunk by chunk and doing this. Now it's started from 590 to 1024. Now 360 to 1034. Now 826 to 1024. The IDs are automatically pasted. Now here, this is the summarized content of my project. Well, while we are doing this, I'll also show that all the other tools are open. First is the flashcard. Let's just click on generate flashcard. It is the same process as the summarizer. It will also take the same time as the summarizer because it will read through the entire uploaded PDF to generate the output. While doing this, I would also like to show you how the flashcard works in the backend. It is like I said, it's the same process. Everything is split into chunk by chunks and is viewed in detail. Look here. There is also not that many changes in the front end since no changes happened there. Hmm, it's still generating. I am working on to improve the amount of time it takes by lessening the time it will take. Currently, I'm only using local models, so it takes quite some time for me to get the desired output. But in the future, I am planning on using multiple cloud AIs or rather APIs to fix and work together to get a better output in short amount of time. So the users will not take lots of time or rather waste the time waiting for the output or rather the answer to come. Since my project name is Flash AI, the output should also be in a flash. This is the flashcards. The flashcard is generated depending on the size of the PDF uploader, where generally the question or rather the keyword is on one side. When you press on it, the remaining words or rather the content related to the keyword will also be present in the back. Now for mind map. We press on the generate button, a mind map will be generated, which makes user easier to understand the keywords or the key topics related to the PDF. As for the quiz, for the quiz, the user can select any number of difficulty. The higher difficulty, that much difficult it would be. I choose hard for this test. Which statement about reading comprehension is correct according to the summary? Well, I'll just go blindly. This is a true or false, which is also a 50-50 chance. So, clicking submit. Well, the first question is wrong, but I got the second question right. Well, the scores also will be displayed, and also the which question is correct and which question is wrong will also be displayed. Now, for the smart search, in the smart search, you can ask questions from the uploaded PDF and the summarized content. It will not just match the keywords, it will also understand what the user wants. For an example, ask something like this. What is the main idea of this chapter? Now it's generating what I asked for and thinking for an answer. Look here, it gave me exactly what I asked for, the proper answer for my question. My project also has a play audio button. If you click it, an audio will play summarizing the entire summarized content, makes the user multitasking. You can just click the play audio and do something else, or rather attend a quiz or study the flashcard, etc. while listening to the audio. You can also copy the summary. Now, I can go back to the main menu and click continue to get to the last session which I left. Now, if I want, I can also save multiple files and also choose multiple files from the load save. Now I clicked on physics and the physics save which I created is loaded. You can also go to the load save and delete it after you're finished with the subject or anything else for the matter. This is the end of my project and end of my presentation. I thank you all for watching this video.